Okay, guys, so day 7 of derivatives unit, the quotient rule. And what we're going to do today is we're basically going to state the quotient rule and do 3 or 4 examples and then do a practice sheet that's about 4 or 5 practice type questions for you to work on. And we're going to keep the video around that 25-minute range or so today because I'm going to get you to do the practice as well today. So I won't go too long. And since we've done the product rule already, it's very similar. So if we're dealing with the quotient rule, we're dealing with a function y that has 2 functions, f of x divided by g of x. Okay, there's a way to derive the quotient rule from the product rule, but derivation of the rule isn't really an area that we're interested in high school level. At this point, we're just interested in using the quotient rule to find derivatives and find tangent lines and slopes and things like that. So to state the quotient rule then, y prime, if it's given in f on top and g on the bottom, it's f prime x times g of x. So derivative of the top times the bottom function, subtract the top function times the derivative of the bottom function, all divided by g of x squared, which is the bottom function squared. So we have to be careful that g of x doesn't end up being, the bottom doesn't end up being a 0, because then you have an undefined slope or whatever, which would be like an asymptote or something. Okay, so if we want to write it in short form, if you like to write it without the f of x's, you can go f prime g minus f g prime all over g squared. That's kind of like how I like to write the equation. Okay, I'm just going to click my timer here so I can see what our time is. There we go. And I'm going to do about 4 examples with you. I'm going to do a really simple example of applying this rule first for example 1. Okay, so let's say we had that our equation was y is equal to 3x over x squared minus, plus 1. Okay, so find y, and we'll simplify this one. Okay, because this one will be simple to simplify. So what I like to do is I like to define my top and my bottom as f and g. So f is at the top, that's 3x. Therefore, f prime, if we take the derivative of 3x, is just 3. G prime, g is x squared plus 1 on the bottom. So if we take the derivative of that, derivative of x squared is 2x, derivative of 1 is 0. So it's just 2x plus 0 or 2x. So there's our setup. So now we apply the rule. Just going to use this rule up here. So y prime is equal to f prime, which is 3, g, which is x squared plus 1. Okay, and then we're going to subtract f, which was 3x, times g prime, which was 2x. So you can see that that's going to be easy to simplify on the top. And we're going to have the g squared on the bottom. And we're not going to expand that part. We're just going to simplify the top and leave this as a x plus 1 squared thing. So if we simplify the top now, we get 3x squared plus 3 minus 6x squared all over x squared plus 1 all squared. So if we combine the 3x squared and the negative 6x squared together, we get negative 3x squared plus 3 all over x squared plus 1 all squared. Now you might think, oh, can we factor out a 3 and get x squared plus 1? Well, no, because it's negative. If we factor out a negative 3, we'd get x squared minus 1, which wouldn't simplify or cancel one of the bottom ones out. So we'll leave it in that form, and that's a good form for our derivative to be left in there in our first example. Okay, now most often I will say find the derivative, do not simplify. Okay, for a more complex one. So let's do a second example that we have where we will use a root in it and maybe not simplify as much. So in example 2, let's try cube root of x minus 5x all over 3x plus 4. And this is going to be equal to our y. So we're going to find y prime and do not simplify. Okay, so we're just going to do the derivative only in this case. Okay, so I'm going to rewrite this out with f and g. So f is going to equal, so let's write this in exponential form. So that would be x to the 1/3 minus 5x. Okay, so if we do the derivative of that to get f prime, okay, the derivative of this is 1/3 x. Okay, and then we have to take 1/3, subtract 3/3, or subtract 1. So if we subtract from 1/3 3/3, we get negative 2/3. Okay, we also have to do the derivative of this part, minus 5, because the derivative of 5x is 5. So there's our f and our f prime. Now if we do g, 3x plus 4. Okay, now we do the derivative of that for g prime. It's just simply 3 for 3x, and then the derivative of 4 is 0. So it's just 3. Okay, so you're thinking, well, we maybe be able to simplify a little bit, maybe not. Okay, let's write the formula so we don't forget what it is. F prime g minus f g prime divided by g squared equals y prime. So let's apply these together into our formula. So f prime is 1/3 x to the negative 2/3 power minus 5, which we can convert to a root if we want, but we're not going to bother. And that's going to be multiplied by g, which was the original here, 3x plus 4. And we're going to subtract, okay, subtract f, which was this here, x to the 1/3 minus 5x times 3. Now we could expand that out if we wanted, but it's not going to help in terms of simplifying anything here. And we finally got 3x plus 4 squared. And that's going to be our y prime. Okay, not any real simple simplifications, maybe a little bit here if you just multiplied that out. You got negative 15x and or if you put it out here and got negative 3x to the 1/3 plus 15x, you could do that. But it doesn't help us because this FOIL would be quite complex. So since it said do not simplify, I'm going to leave it in that form, which is what we do quite a bit in the high school level. The simplification part is asked at more a university level or an EP course or something like that. Okay, so let me move ahead and do a third example that uses maybe a root on the bottom where you're going to do some partial simplification. So sometimes I get you do a little partial, something that's simple that you can just kind of put together and make it a little bit simpler on yourself. So an example number 3. Okay, so let's say we had y is equal to 4x squared minus 3 all divided by the root of x for our value. And we want to find y prime, and we'll say no simplification needed. Okay, I'm going to do the simplification of when we square x, root x is x to 1/2, and we're going to end up squaring it because it's a bottom function. I will simplify that to an x, but other than that, that's probably the only simplification I'll do just because it looks a little better. Well, let's go ahead and do our f and g definitions. F is the top, 4x squared minus 3, and g is the bottom, which we'll write as an exponent, okay, which is x to the 1/2, which is the same thing as the square root of x. Okay, now if we got that, we want the prime to be done. F prime, so we got to go 2 times 4, which is 8x, as we subtract 1 from 2. So that's going to be 8x. And the derivative of -3 is 0, so that's okay. G prime is going to be equal to 1/2 x, and then we're going to take 1/2, subtract 1, which will give us -1/2. Okay, so there is our setup. So again, our formula f prime g minus f g prime all over g squared is equal to our derivative. Okay, so let's go ahead and do this by plugging in our numbers. F prime, 8x. So we'll go y prime equals 8x times g, which was x to the 1/2. We'll write it as x to the 1/2. Subtract, okay, f, which was 4x squared minus 3 times g prime 1/2 x to the -1/2. Okay, not anything really interesting to simplify. We could take a -1/2 out and put it out front and do some fancy stuff like that, factoring stuff, which we do a little bit later on sometimes. But again, that's more a university level. The one simplification I do want to do is if we take x to the 1/2 and we multiply it by 2, well, 1/2 times 2 is 1. X to the 1 is just x. So I like to simplify that because it's real simple. So I would just do that just because I know I can do it. I wouldn't mark it wrong if you didn't, and I said do not simplify or no simplification needed. But if you went ahead and did a simple simplification to make it look a little bit better, leaving all this here same, and then putting just an x on the bottom. Is there a way we could simplify this? Well, we could take an x out of here, but we can't take an x out of here easily. We could, but then we'd have to do some fancy stuff. As you know, you'd have to use a lot of exponential rules. Plus, you'd have to expand this out first before you could do that, and you should probably expand this out first. So you could simplify it further and do some exponent rules type work and get it down to make it look nice and neat. But at this level, what I ask most often is just to do that first step. Get this, plug it into the formula. If there's something simple, like the top crunches out nice, do it. If not, leave it as is my most common question that I'll ask in hand-ins and also in quizzes. Okay, so we're at about 14 minutes. So what I'll do in our last question is I'll do one of those examples where you have to find the equation of a tangent line given to a curve that is in, say, quotient form. So let me get one of those up here. We'll do this on the next page. Or wait, that is a new page. Well, we'll do it on the, we'll have, oops. We'll just make some space and do it on the next page. So let's say I had, and let's change color because it's a little bit different. Okay, so this will be our final example today. And then I'm going to give you some practice work that I want you to do. Just doing the first steps kind of idea. So let's go with a green color this time. Just for something. So our final example for today. Okay, and this would be if you have y equals x squared plus or over x plus 2. And I'm going to say find the equation of the tangent line in standard form. At x equals 1. Or no, that's not going to give me a nice number. X equal 2 will give me a nice number. Let's go, because if we put a 2 there, we're going to get 4 over 4, which would be nicer than if we get 1 over 1/3, which would be a little messier. Let's do it at x equals 2. Okay, so step 1, as we know, is to find that point. We need the point and the slope so that we can use the slope-intercept form of a line to get the line equation. Find the point of tangent C. Okay, so what we do is we plug into our equation. So y equals 2 squared over 2 plus 2. That's why I picked 2 there. I almost went with 1, which would have made it a lot messier. So that's going to give us 4 over 4, which equals 1. So our point then of tangent C is equal to 2 for x and 1 for y. Let's not get those mixed up. I did this example last year or the year before in class one time, and when I went to the final step, I put the 1 in for the x and the 2 in for the y, and it messed up the equation. So keep an eye on, make sure I don't do that again. Step 2, after we have the point, is to find the derivative so that you can get the slope. Now, you don't even have to simplify the derivative. As long as you get the derivative, you can plug with x's, you can plug in the value for 2 for x to get that. So we're going to go ahead and do the derivative of x squared over x plus 2. So we're going to say f is equal to x squared. Therefore, f prime is equal to 2x power root. And g is equal to x plus 2. So then g prime, well, what's the derivative of x? Well, that's equal to 1, right? And then derivative of 2 is just 0. So just there we have it. So then our formula is f prime g subtract f g prime over g squared is going to give us the derivative of that function, which represents slope, remember? So we're going to get the slope at this particular point. Okay, so let's plug our numbers. F, that's x squared, times g. Well, g is x plus 2. F prime, pardon me. I'm not reading my own writing there. That's not f, that's f prime. F prime is 2x. There we go. That's better. That's why I miss having live students. If you make a silly mistake like that, they're like, whoa, hold on. Okay, so let's get g now. X plus 2. Okay, so that looks okay. Minus f. Let's get it right this time. Now it's the x squared. And g is just the plain old 1. G prime. And then we're going to divide everything by x plus 2 all squared. Okay, now you can go ahead, and that's y prime. You can go ahead and simplify at this point. But we do have the derivative, even in its expanded form. As long as you've done it correctly, it's in its expanded form here. So step 1, Step one, step one. What a step one, step two. There we go. All right. Okay, now what we're going to do is we're going to take this derivative and we're going to plug in x equals 2, because that's the point of tangency. We don't know what the y is. Oh, we know what the y is, but we don't have a y. We have a y prime. So, but we do have an x in there, so we can plug in an x value. So we're going to do in step 3, find the slope at x equal 2. So we don't really have to even multiply this out. We can just plug in 2 wherever there's an x. So we've got 2 times 2 times 2 plus 2. That's all of that. Minus 2 squared times 1. Everything is going to be divided by 2 plus 2 squared. Okay, so that's going to give us 4 times 4 minus 4 over 4 squared. Lots of 4s. So this is 16 minus 4, which is equal to 12 over 16. Okay, we can reduce that to 3/4. And this is our slope. Okay, so now we have our slope and our point, and this is where I messed up previously. So let's keep an eye on that. We got 2, 1, 2 for x, 1 for y. So last step, step 4, use slope line equation. Okay, and the slope line equation is y minus y1 equals slope times x minus x1, where y1 and x1 are the points. 2, 1, 2 for x, 1 for y. Okay, so and then the slope is 3/4. 2 for x, 1 for y. All right, 2 for x, 1 for y. Let's double check, make sure I didn't make that mistake again. X, y. Okay, good. Okay, so now we have to get this 3/4 out of there. We can multiply it out here. But if we multiply everything by 4, okay, so this is 4y minus 4 equals, now this is all one expression. Notice there's no, so all we have to do is multiply this by 4, and then we can expand it out later. So 3 times 4 is 12, divided by 4 is 3. Okay, now we can do the distributive property. 3x minus 6. So let's bring everything to the left. So let's add 6 and subtract 3x. So we got our final equation is 4y minus 3x plus 2 equals 0. Okay, and that should be our slope of the tangent line here. Let me just... Okay, and we can say that this is our equation of the tangent line. At the point of tangency 2, 1. Okay, so let's go ahead. I'm about 25 minutes, and let's go ahead. I'll stop the video, but I'll give you the practice. I'll show you what the practice for this is. It's just a sheet of 5 questions. So let me just bring it over here. Let's see, I got to find it here first. Okay, so notes, where is it here? There it is. Okay, so I'll bring it up. Okay, so here you are. There's 5 of them here. You can try it. Here's your answers and then worked out here. This is done by Mr. Friesen, not me, but you can simplify them down, to the simple, like when you have something like that, you notice they simplified that a little bit. Okay. Sometimes it's just written out as one step. So sometimes there might be a little bit of simplification in there, but most often it's just the first step. So that's what you can work on, those 5 today. And I'll keep the video here at the 25-minute range. And we will see you again when we get into our next area, which will be the chain rule. And the chain rule will probably take us a few periods to do. Okay. So I'm going to let you go, work on that practice. Hopefully the quotient rule made sense to you, and good luck.